Welcome to this CipherVibe Cloud Security Guide. Today we will make API Key Security, step-by-step guide for 2026 practical, prioritized, and connected to how real cloud environments are operated. API keys are simple, useful, and dangerous because possession often equals access. This episode shows how to make API Key Authentication safer with ownership, narrow scope, expiration, rotation, secure storage, usage analytics, leakage detection, and emergency revocation. The purpose is not to memorize a collection of service names. It is to build a mental model you can apply when accounts, teams, workloads, and threats change. We will define the core ideas, walk through a repeatable security workflow, examine mistakes that frequently create exposure, design useful safeguards, and finish with a practical hardening roadmap. Pause when you need to. Write concepts in your own words, record observations, and distinguish what the evidence proves from what you are merely assuming. That habit is more valuable than rushing through another tool demonstration. Start with 4 concepts that provide the vocabulary for API Key Security, step-by-step guide for 2026. First, an API key is usually a bearer secret, so any process that can read it may be able to act as the owner. Second, API keys need a human or service owner. Business purpose, scope, audience, creation date, last use time, expiration policy, and revocation path. Third, client-side API keys are not secrets. Anything shipped to a browser, mobile app, or public repository should be treated as exposed. Fourth, quotas and rate limits are security controls as well as cost controls because they limit damage from leaked keys. Fifth, key rotation only works when applications can reload safely and owners can see impact before disabling the old key. Sixth, usage logs should identify key ID, owner, source, endpoint, volume, errors, and suspicious geography or behavior. Do not study these as isolated definitions. Ask which asset or business service is involved, where the relevant trust boundary sits, which identity performs the action, and what reliable evidence would show that the control worked. Security reasoning is a chain. Source evidence supports an observation. The observation supports a conclusion. The conclusion informs a proportionate decision. The decision has an owner, an expected result, and a way to verify it. When any link is missing, say so. A professional explanation can include uncertainty without becoming vague. For example, a network record may prove that 2 addresses communicated, but it may not prove which human initiated the action or whether the content was malicious. Now turn the mental model into a repeatable workflow. First, inventory every API key across gateways, SaaS tools, CI/CD systems, backend services, developer machines, webhooks, and partner integrations. Second, classify keys by owner, data access, environment, exposure surface, last use, rotation difficulty, and business criticality. Third, replace public client secrets with server-side calls, token exchange, domain restrictions, or provider-supported client controls when available. Fourth, define a key issuance process with approved purpose, least privilege, expiration, storage standard, rotation schedule, and revocation owner. Fifth, add usage monitoring for unusual source, endpoint burst, error spike, geography change, dormant key activity, and high-cost operation. Sixth, practice rotation and emergency revocation before an incident so teams know how to replace keys without breaking production. Before acting, define the objective, scope, owner, and success condition. Collect the smallest amount of trustworthy evidence needed to understand the situation. Preserve timestamps and sources so another person can follow your reasoning. Priorities should be explainable. Consider exposure, identity and privilege, sensitive data, business importance, exploit conditions, existing safeguards, reversibility, and confidence. A dramatic label should never replace that analysis. The workflow does not end when a command succeeds, a ticket closes, or a dashboard turns green. Verify the new state with fresh evidence. Check for recurrence and for side effects introduced by the change. This disciplined loop, observe, interpret, decide, act, verify, and learn appears in every cybersecurity specialty. Understanding failure modes will protect you from attractive but unreliable shortcuts. First, long-lived keys without owner or expiry become permanent access paths after employees leave or systems are retired. Second, keys committed to repositories, copied into tickets, placed in front-end code, or logged by applications can be harvested quickly. Third, overscoped keys turn a minor leak into broad data theft, destructive operations, or unexpected cloud spend. Fourth, rotation that requires downtime gets postponed, which increases exposure after leaks. Fifth, shared team keys destroy accountability because logs show a key, not the person or service that used it. Sixth, missing usage analytics leaves defenders blind until cost, abuse, or customer reports reveal the compromise. These mistakes often share one cause: confusing an available signal with a complete explanation. A tool can report a finding, a successful action, or a score while important scope, context, ownership, and verification remain missing. Also resist copying commands without understanding their inputs, outputs, permissions, and side effects. Run one controlled change at a time and record what happened. If an exercise does not behave as expected, that is useful evidence. Stop, inspect the environment, revise the hypothesis, and explain the difference. Good security work is not a performance of certainty, it is careful reasoning under imperfect information. Reliable security uses layers because no single control can prevent every failure. First, store server-side keys in a secret manager, restrict read access, and avoid logs, tickets, repos, shell history, and client bundles. Second, use narrow scopes, environment separation, per integration keys, owner tags, expiration, and default quotas. Third, use gateways or service layers to enforce authentication, authorization, throttling, request validation, and key-level logging. Fourth, scan repositories, artifacts, logs, and CI output for leaked keys, then revoke and rotate quickly. Fifth, create dual key rotation patterns so old and new keys can overlap briefly during controlled migration. Sixth, alert on dormant key use, source change, geographic anomaly, endpoint spike, permission errors, and unusually expensive operations. For each important risk, ask 5 questions. What makes the event less likely? What evidence would reveal it? Who can contain it? How will trustworthy operation be restored? Who owns the decision and accepts remaining risk? Least privilege applies to people, applications, devices, automation, data stores, and administrators. Access should be scoped, separated, monitored, reviewed, and removed when it is no longer needed. Every important control needs a test strategy. Include representative normal activity, negative cases, misuse, dependency failure, and rollback. A written policy is not evidence that a technical or operational control works. Finally, preserve the evidence trail from observation through decision, action, and verification. That history supports investigations, audits, lessons learned, and honest measurement. Turn this episode into a practical hardening plan. Start with inventory. Write down every place this authentication pattern appears, who owns it, what data it can reach, where credentials are stored, how it is revoked, and which logs prove normal or suspicious use. Then reduce the biggest exposure first. Remove stale access, shorten lifetimes where possible, narrow scope, protect storage, add recovery or revocation paths, and make sure high-risk workflows require stronger proof. Next, test abuse cases. Do not only test the happy path. Test stolen credentials, expired credentials, replay, reset, or recovery abuse, wrong audience, wrong issuer, missing logs, disabled controls, and emergency revocation. Finally, measure progress with keys without owner, keys older than policy, unused keys still active, keys found in exposed locations, mean time to revoke a leaked key. Each metric needs an owner, a reliable source, a review cadence, and a known limitation. Strong authentication security is a repeatable operating rhythm. Choose the right pattern, reduce credential theft, validate every token or session, protect recovery, centralize evidence, secure machine identity, and rehearse response. For chapter markers and primary links, open the description. For more evidence-based cybersecurity research, visit CipherVibe.com and subscribe to CipherVibe. Copyright 2026 CipherVibe. All rights reserved. This briefing is general education. Validate controls with authorized administrators in your own environment.